Hey guys, welcome back. We're talking about particle systems and dynamics. And here we have an impulse and momentum and conservation of energy problem. So the scenario is that we have a cart with a hanging sphere below it. And at t equals 0, these are both at rest. And a velocity is suddenly given to sphere B. We're at, which is hanging a distance of L below the cart. We're asked to find VB at the maximum H and then what the maximum H is. So if we diagram the scenario, then at position 1, we have some sort of an initial velocity. And here we say VA at 0 equals 0. Okay, and then at position 2, our sphere has swung forward. This is A, B, and B. And here we have matching velocities. So this is VB, this is VB. And you can notice that the entire system is moving, and if this is the maximum value of H, right? So H is, say this is the starting height, and this is the height now. So this is H right here. So at this H, the pendulum has stopped swinging. So relative to A, it's no longer moving. They are moving in unison. And also, if the sphere is no longer swinging, then it's no longer accelerating A. So the impulse that happened during this time, we don't actually need to worry about. So what we can do is look at this from the standpoint of momentum. And to do that, we just add the mass. Right? So this becomes, instead of it being just V naught, now it's MB times V naught, right? And similarly, this would be MA. And here, this will be the sum of them, right? So MA plus MB times VB, right? And if we use the conservation of linear momentum here, then we know that mv bar is equal to the sum of the masses times the velocities, right? So this is the total, this part, MA plus MB times VB, and that's going to be equal to MB V naught. MB V naught. So solving for VB, which we're asked to do, VB is equal to MA plus MB under MB times V naught. Okay, sweet. One down, one to go. So to solve for H, we need to find an equation that has H. Well, that's where the conservation of energy comes in. So we can use these positions, call this 1, call this 2. So T1 plus V1 equals T2 plus V2, right? And the kinetic energy here, the velocity for v is 0, so it's just 1/2 mb v naught squared plus, so if this is L, then it's mb gl, and I'm going to ignore cart A for the purpose of the potential energy because it doesn't move up and down. Okay, and that's going to be equal to the kinetic energy in position 2, which is this. So it's 1/2 ma plus mb times vb squared. And then the final potential energy is going to be mb g, and now it'll be L minus h, right? So the total distance down minus that much. And these are going to be equal to each other. So let's make a substitution real quick. Let's substitute this. Let's substitute BB for this squared. Right? And we can do that over here. I will say 1/2 of MA plus MB times this squared, right? So MB over MA plus MB times V naught squared, right? So there's 2 of these, and actually, you know what, before we finish this, let's over here, let's divide everything by MB. So it'll drop it out of most of this. So drops out of there, drops out of there, drops out of there, and drops 2 there. Right, so we can bring that over here, MB, and notice that this cancels one of these, right? So this becomes a 1, and then that becomes a 2. So then this drops, and we end up with 1/2 of V naught squared plus GL equals 1/2 of, now it's this guy, so MB over MA plus MB times V naught squared. Note that these will now be able to work with each other, plus G L minus H. Okay, so collect like terms, move this to this side, move this to this side, and over here, well, hold on. Oh yeah, we'll go ahead and do that now. So 1/2, and I'll just put V squared over 2, V naught squared over 2. And so this becomes 1 minus MB over MA plus MB. And that's going to be equal to G times L minus H minus L, right? So this just becomes GH. And to solve it for H, we can resolve this. So notice that in this case, if we wanted to group this together, this would be, well, here, I'll just do it this way. Instead that we'll put GH over here, and we'll expand this. So V naught squared over 2, and we're going to divide both sides by G anyway, so G, and then 1 is MA plus MB, right? So if we put it all together, we get MA plus MB right? And it's going to be one of these, so MA plus MB minus MB, right? Minus that. There, these go away, and that equals H. So to just write it cleanly, we get V naught squared over 2G times MA over MA plus MB. And that is how you get to there. So it's, again, it's not tough material, but when you start working with several particles and in these systems, then sometimes it takes a little while longer to get everything written out, just because there's more bookkeeping. So anyway, I hope that was helpful, and I will see you in the next video.